Click the link in the description to download your own copy of this video's problem. Hey guys, Russ here coming out with another fantastic chemistry video, and today we're talking about formal charge. A little bit more complicated formal charge, not too much though. So let's get into it. Assign formal charge to any atom in the following Lewis structures that require it. All right, so now remember, valence shell, oxygen, nitrogen, chlorine, oxygen. That's what we have to work with here. We have to go to the periodic table, and if you don't already know, find out the valence electrons. So I look at oxygen, I say, okay, oxygen on the periodic table is in group 16 or 6A. That tells me that oxygen normally has 6 valence electrons. Now hydrogen normally has 1. Neutral hydrogen has 1 valence electron. Now, when you're assigning formal charge, count every bond as 1 electron. Every bond is 1 electron. When you're assigning octets to Lewis structures, every bond is 2. But for assigning formal charge, consider every bond as 1. Okay, just consider it that way. So hydrogen has 1 valence electron when it's neutral. It has 1 bond in all these cases. It has 1 bond. So hydrogen is what we call neutral. It doesn't have a formal charge. Carbon, 1, 2, 3, 4, has 4 bonds, normally has 4 valence electrons. The carbon is also neutral. However, the oxygen is not. Oxygen normally has 6 valence. 2 for the lone pair, 3, 4, 5. Now it has 5 valence. Now it has 5 valence. So it has 1 less negative than it's supposed to. 1 less negative than it's supposed to. So it will be positive. The oxygen in this case is positive. It has a formal charge. Hydrogen and hydrogen each have 1 bond. Hydrogen is not charged. It has no formal charge. Carbon has 1, 2, 3, 4. Carbon has 4 bonds. It normally has 4 valence electrons. Therefore, it is not formally charged. Nitrogen, however, has 5 valence electrons. This one has 1, 2, 3, 4 bonds. That means the nitrogen is positive because nitrogen normally has 5 valence electrons, and in this case it only has 4 bonds, so we only count 4 valence electrons. That means the nitrogen has lost a positive charge. Nitrogen has lost a negative charge. That means the nitrogen must be formally positive. Over here, chlorine. Chlorine's in group 17 or 7A. So chlorine normally has 7 valence electrons. That's for chlorine. Oxygen normally has 6 valence electrons. It has group 16 or 6A, 6 valence electrons. Let's look at the chlorine. 1, 2, 3, 4, 5, 6, 7. So chlorine has 7 valence electrons. If you count the single bond as 1 electron, it has 7. That means the chlorine is neutral in this molecule, or this ion. Chlorine doesn't have a charge. Let's count the oxygen. 1, 2, 3, 4, 5, 6, 7. The oxygen has 7 valence electrons. So it's the oxygen that has 1 more electron than it does if it's not neutral, if it is neutral. So that means the oxygen is negative. The oxygen bears the negative charge. And you're going to start to see patterns. Oxygen with 3 bonds in a lone pair, positive. Oxygen with 1 bond and 3 lone pairs, negative. Nitrogen with no lone pairs but 4 bonds is positive. You're going to see these patterns repeating over and over again. But for now, it's important that you learn how to assign it the hard way, let's say, or the manual way. All right? All right, guys, now with that, I want to say, if you like this video, please go ahead and slap that like button. Leave a comment below. Let me know how I can help you in your organic chemistry career. And if you could, please subscribe to my channel. It really does keep me motivated and hyped up to keep making more content for you guys when I know that you guys are subscribing and finding it useful. And if you could, just share this content. Let your friends know that I'm out there. Let your friends know that I can be helpful to them in their organic chemistry endeavors, I guess you could say, as well. And with that, I want to wish you all good luck and good chemistry. We'll see you soon. Email drbetts@protonmail.com if you would like a copy of every problem in this series.